Hey, Algebra 2. We are going to simplify some radicals here. And again, this is hopefully some review from Algebra 1, but we want to clear up some things before we get into too many quadratics, get into that quadratic chapter that I know you're going to love, because we can see quadratic formula later on. All right, we're going to deal with this in two separate things. We have some numbers under the square root, and then we have some variables. So what are the factors of 100? Okay, so that's one way we could work with this. My hope is that I am working with some kids that remember their perfect squares. You know, the square root of 100 is 10. And then keep in mind, n cubed means 3 of these. And what we're looking for with a square root is pairs of things. So that means I have one pair, and what's left over is one of these n's. So that's how we're going to deal with that. What was nice about this one is we did have a perfect square. So let's slide over here and take a look at 120. So I don't know what factors you would like, but typically if I see a 0 on, I'm going to take that 10 and whatever number that is. So let's take a look at what happens after we do some more of this. Ooh, 4 and 3, 2 and 5, 2 and 2. Okay, so keep in mind, since we're dealing with square roots, right, because there's no number in the index right here, it means I'm looking for pairs of things. So if I write this whole thing out, it would actually be 2 times 2 times 2 times 3 times 5, right? So those are the bottom of that factor tree. And I'm looking for pairs. Everything else goes back together by multiplication. So far, the only thing I know is 2 goes out and 30 stays in, right? Because I'll have 15 times 2 is 30. And if I have b to the fourth, that means I get 2 pairs of those. So I'll get b times b or b squared. So that's a simplified radical to deal with that. All right, what about 66 t to the fifth? Well, that's 6 and 11, and that's 2 and 3. Oh my goodness, look, nothing happens, right? I don't get any pairs out of this. So it's going to stay root 66, but t to the fifth. So if I had 5 t's, how many pairs would I get? You're right. There would be 2 of them, but I'd have 1 left over. So that's what we're going to get for our final simplified answer. All right, let's slide back over so we go somewhat in order. All right, 32. We have a couple different ways to go about this one. I would like to think 2 and 16, but I think more commonly kids are going to say, well, that's 4 times 8, and I'm okay with that. And then this is 4 times 2. All right, now remember, we're looking for pairs. So whenever I get those, I can stop. So I don't have to do like I did kind of in the middle school or somewhere else and work completely to those final factors. As soon as I see a pair, so that's 4, and then I have a square root 2 because the 2 is all by itself. And then I have x to the first power, so it's going to be left over underneath that square root as well. Now, a lot of kids at this point, they're like, well, how do I know I'm getting this right? Because this seems weird. This is different. Okay? And how do we check it? Here's how we check, okay? If you take the number on the outside, and this is for numerical, and I square that, that would give me 16. 16 times this 2 gives me 32. So that's how I can check it. So I'm going to get those out of the way because that's not part of the answer. Right? So you can square the number outside times the number inside. You should get the number we started with. All right, 525. What do you got there? That seems like 25. How many quarters is that? Okay, so if you haven't already, you want to start grabbing your calculator so we can double check some things. 525 divided by 25. Okay, that's 21. All right, so what are we going to do with some of those numbers? Let me fix this while we're dealing with this as well. All right, so this is 5 and 5, and this is 3 and 7. Well, I have a pair of 5s. These will go back together as 21. So I have 5. I'm going to leave a little space for some c's, square root 21. If I have 7 of them, okay, that means 6 is even, so that's 3 of them, but I'll have 1 left over. So I'll always know that I should have 1 left over if this number is odd. Okay, if it's even, then we're just going to divide it in half. How could I check it? 25 times 21, well, that's what we had right here, so I know that it's correct. 86. 86. What do you want to do with 86? Okay, a lot of kids are going to say, well, that's divisible by 2. You're exactly right. That's 2 and 43. What can I do with 43? Exactly. All right, so there's nothing we can do with 86. All right, so that's going to stay under the square root, but I have t squared, which makes 1 pair of t's, so that's going to work its way to the outside. So sometimes that happens. All right, and when we eventually get to the quadratic formula, that's going to be a good thing. I threw some fractions on here too. Keep in mind that if we're dealing with a fraction, I can deal with this as two separate ones. So what's the square root of 49? 7, good. And the square root of 81? 9. Okay, so we're kind of done with those. All right. The other thing I can do is I can reduce what I have going on in here. So 18 and 200, they're both divisible by 2. Okay, so I can make this 9x to the 4th. And I'm also going to separate it while I do that. And it's over 100. So what can I do with this? All right, so that's 3x squared, right? Because the square root of 9 is 3. X to the 4th gives me 2 pairs, so everything's on the outside. And the square root of 100, we said in the beginning, was 10. So that one's beautifully done as well. So not only can I reduce the numbers, I can also reduce those variables. So that's why we talked about your exponent rules. So this becomes 28 over x squared. I'm going to go ahead and separate that into two separate problems. The bottom, super easy, right? X squared. We're going to take the square root of it. So it's just one pair. So x to the first power, 28. What do you want to use? 4 and 7, right? So let's make that 2 and 2. So I have a pair of 2's. So where does that go? The inside or the outside? The outside. Good. 2 square root 7. And it's over x, right? These are my square root signs. It's early, you know? Okay, so I get some more fractions going on down here. If I can get this to move a little bit more. All right, so we just want to use a combination of, 25 over 9, nothing going to happen. But we really like those numbers because they're perfect squares. So I know this is going to stay square root 25. This is going to be square root 9. And who has more a's on the bottom, right? So that's going to be a squared on the bottom. This is going to work out really nicely. We get 5 on the top because of perfect square. On the bottom, square root of 9 is 3, and we have 1a to go with it. All right, so I'm going to work with these first. I'm going to end up with a b left over. It's going to stay inside as I reduce those. What about 40 and 12? What can I do with that? They're both divisible by 4. So I'll have 10b over top of 3. All right, and we have a square root. And that's pretty much all we can do with that at this moment. Okay, we're eventually going to figure out that I cannot have square roots in the denominator, and we'll work with those later in the chapter. Okay, but I just want you to get in the practice of reducing it first, and then seeing if there's anything we can do with it. All right, 48 over 6, I believe that just turns into 8, right? And that's going to be over t to the 6th, and I'm going to put these both over the square root, or under the square root. All right, so t to the 6th on the bottom, right? Hopefully at this point you realize the variables are actually the easy part. So that means 6, you got 3 of them. And 8's made up of 4 and 2, so that's a pair of 2's with a 2 left over. Let me just try and clean up my square root sign. All right, and that's all we have left with it. Okay, now we're starting to get some of these things happen, right? If these were, let's say this was 2, well, it is 2, and let's say this were 4, then I could reduce the fraction again. But by reducing in the beginning here, we're hopefully, when we do this 48 over 6, we're hopefully going to eliminate most of that reduction. Okay, but I just want to point that out so we know, later on they might say, hey, there's another step we can do. All right, so what we're going to do is start to introduce some of these operations. And multiplication, it may seem strange that normally we start with addition and subtraction, but multiplication actually becomes one of the easier ones. So I don't really need you to show off and tell me what 6 times 30 is, because I just want to reduce all these. And what I don't want to do is break down the 6. If I know that 30 is divisible by 6, I want to use that so I can get a pair of 6's right away. Remember, I don't have to do a complete prime factorization. I'm simply looking for pairs because right now my square root, right, this index number, using some vocab on you, this index number is 2. So that means if I had square root of 6 and square root of 30, it actually turns out to be 6 square root 5. How can I check that? Remember, if I take 6 and square it, that's 36 times 5. Would 36 times 5 give me the same thing here? And it does. Okay, so it checks out. All right, so using that idea, right, I'm going to make this into one big square root. So 5 times 70. And what I'd like to do is make a pair of 5's. So I'm trying to figure out that 70 divided by 5 is going to give me how many? I can't hear you. Right? 14. Now 14 turns into a 2 and 7, but I don't make any pairs. So I strike that one out and say my 14 stays in. So that means we believe it to be 5 square root 14. How do I check it? Is 25 times 14 the same thing as 5 times 70? And it will be, because you're awesome. All right. The next thing we do is give you just a little bit more going on with these. So now there's an extra number out here. We're going to ignore that until we're completely done. All right, so I'm just going to leave it hang out here. 3 times 96. So obviously, right, we want to try and see if 96 is divisible by 3, and it is. Right, we're going to get 32. And so far, that's been all we could do with those. But remember, 32 may have some other pairs in it. So let's see. We had that one before. We said 4 and 8, right? And then it said 4 and 2. So I have this as well. So I'm getting a bunch of numbers for the outside. And the only thing left over is this plain old 2. So here's what I have so far. Yeah, I got some space. I have this 2 that was out here. I have a pair of 3s. I have a pair of 4s. And I have a square root of 2 left over. Okay, so that means I got 6. We got 24 on the outside and then the square root of 2. So this is where it might be thrown off a little bit when we go to check it. Okay, so I wouldn't check completely. I would ignore the 2 as I go to check it. And I want 3 times 96. Is it the same thing as 12 squared times 2? And we'll find out that it is. So that's how we deal with multiplication. And we can do all sorts of fun stuff and throw in some variables as well. All right, so again, I don't really want to multiply anything together at this point. I just want 3/4. I want it times 2. I have the square root. I have 12 and 20. The variables, that might be the only thing I am okay with putting together because it's super simple, right? We have the same base, so we're going to add 3 and 4, and we got ourselves an x to the 7th. So what common factors do you think of when you have 12 and 20? My hope is that you see a 4 in there. Okay, so it means this 4 is going to bump out to all this other stuff. So I got 3/4 times 2 times 4. I'm going to end up, a little space here, I'm going to end up with a 3 and 5 left over. So remember, this is multiplication, so 15. 5x to the 7th, I'm going to have 1 left over. That gets me to 6. That means there were 3 pairs. So we just have to clean up all these numbers on the outside. And I don't know about you guys, but when I see this 4 and this 4, I want to get rid of those right away. So that means numerically I'm down to 6x cubed square root 15x. Okay, so again, remember, you want to ignore any of these extra numbers if you go to check what you're working on. As far as just double checking the number itself, I want to make sure that 4 squared times 15 gives me the same thing as this 12 times 20, and then I know we're in a good place as far as working with those operations. All right, so we went from just breaking one down to show you how we can divide to simplify, and then also multiply, multiple of them. Okay, notice all these have the same index. So just preview some things we want to do. That way when we do the quadratic formula this year, we're not going to use decimals. So I want to give you the reason why we're doing it in this order. But you have to trust the process. And we're just trying to do each thing in front of us very, very well. And then the grand scheme of things, it'll be super easy later.